Okay, my talk is what I've called self-aware autonomous systems. And okay, maybe one word about the word self-aware. There's been many discussions. I use the word self-aware not maybe related to human self-awareness, but it's what we see in autonomous systems. And what we see is something is missing there, in our opinion, in the current development of autonomous systems. And yeah, from that perspective, that is probably something that could be related to self-awareness in humans and why humans are self-aware, and also probably on introspection. But we'll discuss about it. Plenty to discuss it. So applications. For us at TNO, we are working on in the civil domain autonomous vehicles and also cooperation between those autonomous vehicles and platooning, self-awareness, trying to communicate with each other and what to communicate and whatnot. In the military domain, underwater mine hunting, swarms for surveillance, frigate autonomy, also frigates cooperating in a task group, as well as on situational awareness on cooperative actions. And also recently, meaningful human control for autonomous weapon systems, which is a pretty tricky subject, because what is meaningful and what is not. So a lot of questions also come around, and what do humans do and what can machines do? And also a lot of discussions about what is autonomy, and levels of autonomy. To us, it turned out to be not very useful. We have a system perspective, where we want to make systems on what we saw these examples, on which are to be most what we call cost effective, or actually, so from the system engineering perspective, it's not that we advocate a typical kind of algorithm or method. It's only that from a system engineering point of view, what are utile methods to use? What are utile things to do? And also, what are useful system models then to use to make these type of systems? And there are three aspects of autonomy, which in combination, to our understanding, makes these systems truly autonomous. And that's what we could call automation. Automation is actually about algorithms which do situation assessment, so they, in terms of the OODA loop in the defense domain, they observe, orient. Algorithms with situation management, so they do the decide and act part. Developments in these domain, for these algorithms are they can deal in more complex situations, with more complex situations and higher levels of autonomy, so levels of information abstraction, both on situation assessment and situation management. And better cooperation between the autonomous systems, so they can cooperate in a better way. Advantages is that fast and transparent. And disadvantages not dealing well with failures and unreliable resources and unexpected situations, and development in more complex algorithms. Also, the models which have to be used become laborious. So just a number of problems if you only use this type of autonomy. Then you can say, well, we can use learning because we can learn those models, and that become complex models. We can do online learning, learning on the job, or offline learning, training, and development there, faster learning, faster computers, which make it now much more interesting to look at learning because computers are much faster than they were. But also more efficient algorithms are still needed. It's a very flexible tool. You can use like to learn everything. The disadvantage is it's still very slow, complex systems in complex situations. It's difficult to understand how and why it works, and inherently unpredictable and also deceivable if you use it online. and not dealing well with sudden things like failures, unreliable resources, and unexpected situations, because it can only deal in general with what it's learned, and if such things happen, you can say, well, learn on the job, but that takes a long time, and if you do that for critical applications like autonomous driving or military applications, it's probably not a very good idea to do trial and error on the job. So still limitations to this. But still, this is all we got. I mean, for most systems now in practice, this is all we got. And the role of the human there is that cooperation with these autonomous systems and system assessment, situation assessment, situation management, is that the human actually creates the model of the behavior of the system. So it gets this information and support, but still it has some kind of a model of how the system works. And the system is not very responsive to the human. The human is still the fail-safety agent, because if things go wrong, then okay, what is going on here? What's going wrong? It needs that model of the system, and then it can intervene or try to intervene and fix the problems or try to solve failure. And it's also a moral agent. So the human makes the moral decisions and intervenes with these autonomous systems and think, well, this is not what is intended in terms of ethics or moral decisions. So, in general, a number of challenges. We can make those systems that can cooperate in complex situations and reach complex goals. So how we do it? It has to be safe, cost-effective, can self-explain itself, needs to be behaved ethically and also within legal constraints. And how do you test and evaluate those systems? I think the underlying problem to all of this is that you have what you call an explosion of the state action space for this complex systems, complex environment. So, actually, for example, you cannot learn everything a priori how the behavior of a system could be, because the number of actions, both external and internal actions, because we're talking also about introspection and about self-optimization. So we do not only have to reason about what actions to take in the outside world, but also what actions to take in the inside world. And if you don't want to reason what actions to take, and you can, in what different type of situations, it turns out to be that for every practical application, there needs to be, you have to a priori reason about an enormous reduction of your possible state action space. So there has to be in our opinion, there has to be a conscious choice how you reduce your state action space, or your problem space actually, which you are going to tackle. You cannot tackle the whole problem. It's NX complete. It's well known from for example, the important learning that in distributed systems, the state action space is complete. So, in our opinion, one way, or maybe the only way out of that problem, is that you actually have a system which understands the situation, both externally and internally, and that it can adapt and reason its way out of that particular situation. So that is actually this kind of feature, what we call self-awareness in an autonomous system. And it involves self-assessment, so it's only a few examples. So actually anything can be, any functionality or any feature of a system could be knowledgeable for some kind of self-awareness. But at least you have resources, energy, sensors, computation, communication, actuators, and it also has to understand how well it is doing. So how well is it doing situation assessment and situation management? And it's also part of self-awareness is knowing how to manage yourself, knowing yourself, then you also have to know how you manage yourself. And very important thing, to reach your goals. So actually the meaning or what now we have in quality measures actually can be redefined in this context, in actually how futile it is to reach your goals. So there are no implicit, even in the end, that's our hope, our view, no implicit quality measures on every different functionalities, but actually that you have runtime reasoning about how futile it is to reach the goals at that particular moment for that particular situation. So there's much faster adaptation than could be done with learning. And a lot of people from artificial intelligence, when you talk about adaptation, they immediately say, well, we have this learning algorithm, that learning algorithm. But if you have good models of yourself, which you usually have because you built the system. So it's not that it's not that normal that you say, well, we start learning because you already have a good knowledge of yourself. So you only should learn about yourself that what you don't know about yourself. It can do much better with failures because it can reason, okay, now this sensor is broke, so I missed this type of information, and I understand how utile this information is for the goals I want to reach. So then I can reason what is the optimal setting of my system, knowing that this sensor doesn't work. Just an example. And it can explain also better what it's doing and why it is doing to humans, for example. Because it has an understanding of the goal, and it also has an understanding of its internal performance towards that goal. And such a feature could also be regarded as some kind of online continuous testing evaluation capability. So there is a lot of problems now with testing evaluation of these systems. But this could be regarded if you implement it in the system itself. Part of the problem, of course, is related again, with testing evaluation, to the explosion of the state action space. You cannot test all your states and all your actions in those particular states. Those problems are very much related to each other. So the world human would then be, there's a much better cooperation on situation system, situation management. And cooperation of the autonomous system, fail safety could be part of the capability of the system itself. So, which is already known that humans in a lot of situations, if the system fails, they don't have a clue what to do. So, if we have to autonomize that also. And particularly for what I mentioned on autonomous weapon systems, or even also for autonomous cars. There's also this problem in cooperation on moral issues. Well, there seems to be quite a confusion there, but because a lot of people think, well, these systems start to make moral decisions, but actually we can make a separation in the system. You want to make a system which is able to reach its goals in the most cost-effective way. What those particular goals are is still up to you. Well, there are a lot of people who think, well, if you go to autonomous systems, then start making the decisions on these issues. Well, finally maybe, but for now. And then something on engineering those self-aware autonomous systems. There are a lot of system models, so most people have their own favorite system model and start from there. And I think there are so many different ones, and they're all different. But there's not much understanding or consciousness about why they're different and what you're missing if you take a certain model. So you should think about system models which at least a priori do not limit or already make it not possible to implement certain functionalities. Yeah, and self-awareness should be, from a system engineer's perspective, again, an explicit choice. So, I mean, you could make an algorithm which is aware of any type of functioning inside of the system. But again, that would not be very cost effective because that would be so much overload in computation. So you should only make those parts of your system self-aware, which actually give a large performance increase. And that is particularly the case for very dynamic situations in which certain system performances give different certain system in certain situations. How the system is configured is much better performance. So it's very dependent on the situation. Let's put it that way. It's very, the performance, how the system works, the performance of it is very dependent on specific situations. So then it needs to be aware of the specific situation and change itself such that it works for that particular situation in the best possible way. Yes, there's another discussion, particularly if you want to autonomize things, about goals. So people used to talk about goals in which they actually say, well, for example, take the example of the mine hunting. You ask people, what's the goal of this system? Well, the goal is to find all the mines in this area. But an autonomous system cannot, I mean, it's only the ideal situation, finding all, but it has no clue how bad it is if, for example, there would remain one mine or there would remain two mines. So you need actually, you need a goal function instead of a goal. So you need to actually specify all possible outcomes of the system or the actions that the system takes and all possible outcomes of that and have some value attributed to that. Another thing is if you want to apply that then and say, okay, we have values in our goals and we also want to make ethical decisions, and there's also quite a reluctance to make those values explicit, which we need to specify the goals. But this also opens up a lot of new possibilities in human-machine interaction as well. So because these systems start to understand what they are doing and why they are doing it, and can interact with humans in a more natural way. And that's what we found out is quite a difference from the traditional human-machine interaction with autonomous systems. And it's also even the question whether the human is still reasoning about these end goals. It could also be that the system reaches about the end goals, and the humans, and the system gives advice to the human about this. Well, according to me, this is the best possible solution to the end goal. And then the human say, well, I think it's way different. So you can have an active interaction between humans and systems on this level. So a few considerations. Situation awareness is an important development aspect in autonomy for a number of reasons. So cost effectiveness and better cooperation with humans, online testing and evaluation, and saving good behavior. And in my opinion, this self-awareness is also very related to introspection, as we've been discussing it here. Because, but we can have a discussion about different forms of introspection, because it could be what I haven't heard until now is, and in my opinion, also a very important reason for introspection is that you have an online adaptive goal for your different functionalities in the system. So you take the active learning, for example. You could say, well, I need not to be overconfident or underconfident. But if you can relate it to your end goal, you can also say, well, how good should it be to reach my end goal? So the system starts to understand in terms of performance and good or bad, and even computation, communication, you can reason about how utile, as we call them. All these different aspects in the system are related to the dynamic end goal. The more more powerful autonomy becomes, the more important the question becomes, how should it behave? We see it already in autonomous vehicles, that for there you could even argue that these autonomous vehicles are better at decision making because they are faster. So they can make decisions in 10 per second, and particularly if you have cognitive driving, it's even more dramatic. Because these systems can already anticipate what they are going to do and exchange this information to other vehicles in which already can behave, anticipate on what the other vehicle is going to do. But then, of course, we need also to think about what then a good decision is of these systems to make, because the human cannot make it anymore. But it's better that the system does it. But how should it decide? And from that perspective, we also see that there's a shift from formulating also what is good and lawful, because that is also related to what is it good behavior according to the law. But that's determined into rules and norms and constraints. While we see that for these advanced autonomy, we have to formulate it more in terms of goals and values. Yeah, and from that, because they can understand the situation and how to adapt to the situation, actually what they do is they derive the rules and the norms themselves for that particular situation. So actually what is now, we have the law, and every human should understand and know the law, which they don't, but that's the assumption. And then there's a judge who says, well, if it is in this particular situation, maybe it was not as good or bad. So there's an evaluation, actually, by the judge afterwards, or how good or bad that particular action of the human was. And actually, this kind of reasoning for advanced autonomy, what the judge now does, should be done by the system itself. And so it derives actually the rules for that particular situation. So, for example, it's not okay to kill a human, but if it was a terrorist attacking 10,000 people, or then probably a good idea to, if there's no other option. But this kind of thing should also, systems should be able to reason about. Like for autonomous cars, even. So that's not that far away as people think. So it was my presentation.
Good question. Yeah, so you said that the robot should derive the rules themselves, but the rules are then dependent on the model that you have, kind of relationship to perform, how to figure out whether they're failing or not.
Yeah, this is quite a high overview talk, and so one of the biggest challenges I think is to the optimization. It's again terminology. Some domains call it optimization problems. Others see it as kind of feedback mechanisms into a system, feeding back the high level goals actually to lower levels. However you want to do it, and we see that, again, this is a matter of cost effectiveness, how you can do it best. That's one of the most challenging problems. So how do you relate actually your mission goals in terms defined in terms of values and functions to what actually good performance or rule should be anywhere in your system for a sub-function actually in your system. So take the example of the active learning. How do you know what kind of classification or what kind of classes you would like to do your classification in, and how accurate you would like to do that? Normally now it is done with performance rules actually. So how good it should be is more or less design time determined by some kind of performance rules, measures, whatever you call it. In the future, you would like a more and more dynamic, you could call it quality control, you could, in many different domains, it's all comes down to the same problem, and that is that given a particular situation, being aware of that situation, actually what you try to solve now or do usually choose design time, start more and more reasoning about that runtime. And finally also, then you can afford, but that's quite far along the line, also to start thinking about how you could derive sub-goals and not sub-rules.
Any more questions? So I have none, because basically through your talk I had this impression that for you introspection is happening somehow to making machine compliant to human norms.
No.
Okay.
The most important, well, that's actually, I think the first one is the most important. So, in my opinion, everything can be related to cost effectiveness. Why are we reasoning what is better than something else? Finally, it's about cost effectiveness. Is it whether it's faster or cheaper or whatever? And then finally, I think it's about money, but okay, that's another discussion. And so, yeah, so the point actually is if and cost effectiveness is all about reaching your goal in the best possible way, then introspection actually, what it does, and I think the example of active learning was a good example also, that you want to have some meta knowledge of how well am I doing. So the first thing is that you want to understand how well am I doing. How well am I doing my classification or tracking or whatever you would like to do. And the second part of the problem is, but how well, what is my, I have to define it in some type of utility, and so how well am I doing? I could, now we have local measures like track accuracy or continuation or whatever you like to call it in classification, also a zillion performance measures. I've been in many discussions about performance measures and everybody starts quarreling about what is the best performance measure and what's not. Problem is they don't reach a conclusion because they do not relate it to the end goal. So they do not relate it to a performance measure, or utility actually, which is utile, reaching that goal actually what the system has. And if you realize that that sub-goals, like how important is classification or how important is tracking anyway, or with accurate, that is again depending on the situation, then you understand why nobody ever reaches a conclusion on this, because that was actually what happened. And I think we had 30 performance measures of tracking and classification, for example. And then everybody, well, what's the most important then? Then let's ask the operator what define it. And that's actually what the answer is, because it depends on the situation what the operator will think is important. But if you start a discussion with an operator, he will say, well, what have you got? So you get again in a very complicated loop. So one of the challenges, of course, is okay, how can you make those systems then? If where do you start? How do you? So finally, it's up to the system designer, actually, I think, to understand what the operator needs, because he cannot. So.
Thank you. Any more questions? So I would say that now we can have a lunch break. We start again at 1:15 with the continuation of the invited talks. And I would like to remind all authors of all the papers to send me an email the live presentation that is prepared for today. Thank you very much, and see you at 1:15.